Once the recorder starts. Yes, Annalise. Okay, listen. Briar. Okay, our objective today is to continue simplifying radical expressions. There is an extension to this lesson that I would like to do today, but I need to see how you did on homework and how you're doing with perfect squares. Okay, so before we start, Donatus, what's the square root of 121? 11. Annalise, what's the square root of 196? Good, 14. Jeremy, what's the square root of 225? Good. Adam, what's the square root of 361? Hey, Jeremy, quit. Do not yell things out. I mean it. Okay, 19. Briar, what's 20 squared? What's 20 squared? There is a 20 squared. I'm changing it. So you guys have to think. What's 20 times 20? 20 squared is 20 times 20. Sean, what's the square root of 9? Briar. Good, 3. Zach, what's the square root of 4? Good. Justin, what's the square root of 1? Okay. Alyssa, what's the square root of 169? Say that again. 13. Good. Matt, what's 17 squared? What is... Yeah, it's a very difficult question. What is 17 squared, Manatee? No, that's 19 squared. You have to have, eventually you guys have to have them memorized. No, that's 14. Okay, Emma, help him out. What's 17 squared? Annalise, turn around. Okay, you guys have to have all these memorized. 289. Mary, what's 18 squared? Nope. 18 squared is 3 something. Nope. Sean. Good. 324. Adam, what's 15? Briar, face forward. What's 15 squared? Good. 225. Donatus, what's 16 squared? I'm waiting. Nope. Donatus. Sorry. Charles, what's 16 squared? Oh, come on. You're supposed to help us out. Zach. Good. 256. Jeremy, what's 17 squared? Okay. Emma M, what's 18 squared? Good. 324. Charles, what's 19 squared? Don't yell out answers. Especially you. Manatee likes to ask 3 times. What did you ask? What is 19 squared? He started doing this head. Nope. Think about what it ends in. 9 times 9 is 81. 361. All right, Sean, 20 squared. Go ahead. We're going to get to that. Don't ask me that yet. 20 squared. Okay. Annalise, what's the square root of 196? Good. Mary, what's the square root of 289? Good, 17. Adam, what's 17 squared? Okay. Emma M, what's 18 squared? 18 squared. Oh, yeah, you're good. Sorry. Thinking of my next question. Briar, 19 squared. Okay. Manatee, square root of 400. Okay. One more. Frodo, 11 squared. Good. All right. So, guys, eventually, you need to make sure you know all those. I'll keep doing that at the beginning of every class. Okay, homework. Number 1. This was page 136. Okay, we are on the board here for a little bit. Number 1 is 10. That was really easy. I hope you all have that. Number 2, 5 square root of 3. Number 3. Charles, what did you get? Why'd you say either? Do you have two answers? All right, so negative 12a is what 13 is. Number 4 is not right. It's okay. Anyone want to fix number 4, Alyssa? Good. 8x square root of 2x is number 4. Number 5 is missing. Adam, what did you get for number 5? Bless you. No. Justin. You're getting closer. John. Good. 20 square root of 10. Number 6 is not right. Manatee. Good. A to the 4th square root of 15b. Number 7 is not up here. Emma H., what'd you get for 7? Good. Number 8 is 6x squared. Perfect. Square root of 3xy. That one's right. Number 9. Someone just couldn't read their writing. This is a y, not an x. So number 9 should be negative 2y square root of 5x. Number 10, Alyssa, what did you get? Wait, number 10. 2a. Yep. Donatus, number 11. Good job. Number 12, Charles. Square root of what? No. Your 2 things are off on yours. You guys, something stumped you guys. You guys are not like amazing at these yet. What's going on? I'm just kidding. Emma, go ahead. Emma says she's amazing at them. Go for it. You are amazing, Emma. Nice job. All right, Arwen did it too. I got to learn that one. Okay, 13 is correct. 3a square root of 3. Now we get into the really hard ones. Well, 15 and 16 are harder. 14 we need. Frodo, what did you get put for 14? Great job. Very, very good. All right, you guys are getting there. What? Oh. Manatee, do you have problems reading numbers? Manatee, we got to work on this. Is that why? Are you really playing your part now? All right, 15. Zach, what'd you put for 15? No. Something in the front of your square root is incorrect. Justin, what did you get for 15? Okay, you forgot something too. Annalise, what'd you get for 15? Good job. Oh, that's an N. So it should be 9m squared n square root of 3m. Okay, 16. Negative 8. Y to the 4th, you mean? That should have been a y. Negative 8y to the 4th, z to the 5th, square root of 5y. Perfect. Besides not reading your writing, Frodo, perfect. So I feel like some of you guys are there, some of you are not. So if you missed 1 or 2, that's great. Raise your hand if you missed 1 or 2. Anyone get them all right? Raise your hand. Ooh, yay. All right. Okay. All right, so let's spend about 5 minutes. Homework questions. Adam. I know what you mean. Yeah, the number. So if something's perfect, okay, if it's inside a square root and it's perfect, you take the square root of it, you move it in front. Okay, once you move it in front, you cannot simplify it anymore unless you're just multiplying things together. You only take a square root when it's perfect and it's inside the square root symbol. When you move it in front, it just stays there. That's what you asked, but that's not what you meant, I'm guessing. Yeah. Why do you get 9 outside? You don't get 9 outside. So 13. 9 is not outside. Listen. So 27 breaks down into square root of 9, square root of 3, yeah, square root of a squared. You don't put 9 outside because 9's perfect. So my point, Adam, is when something's a perfect square, circle it, move it out front. Whatever's not perfect stays inside. That's why yesterday I wanted you guys to circle what's perfect. Whatever's perfect moves out of the square root house. Okay, it moves out. From that point on, you leave it in front. You do nothing else with it. Annalise, what number? Well, okay, pick one so I can get to everyone. You never, ever, ever change them to decimals. Ever. Annalise, you should not be using your calculator for any of these. No decimals. You're finding the perfect square that, that goes into it. You're never, ever, you should not be using your calculator for any of these. So if you change number 5 to square root of 10 times square root of 100, that's the same thing as square root of 1,000. And we know that 100 is perfect. So square root of 100 is 10. So I'm going to write that in front. And then you drop down what is not perfect. Do not ever do that on simplifying radicals. Unless it tells you to estimate the square root by changing it to a decimal, but in geometry, you will never do that. Manatee. Okay, good question. So if you don't find the largest perfect square, that's okay. But then you want to ask yourself, is there another perfect square that goes into it? So try 4, try 9, try 16, try 25. You know what I'm saying? Just go through your list of perfect squares again and make sure none of them go into it. Eventually, you'll get like I do, and you'll just know whether a perfect square goes into it or not. So we're going to do more of these today. You'll get better. Good. So if there's another one that goes into it, you just split it up again. Whatever's perfect that you're taking out of the square root, it goes in front, and you multiply it with the numbers in front. So you just repeat that annoying process over again. That's why I showed you both ways yesterday, Matt. If you do use the largest perfect square, it makes it quicker. Manatee, sorry. Alyssa. That's fine. Whenever I say don't use the calculator, like don't type in second square root of 200 and change it to a decimal. You can use your calculator to figure out what perfect squares divide into that number. Yeah, that's fine. Just don't use the calculator to change the square roots. Frodo. Yeah, go for it. Hey, do you need anything? Okay. You okay? All right, Annalise. Go for it. Yep. All right, let me just do it then. The number 6, we have square root of 15, a to the 8th, b. So split them up. Square root of 15, square root of a to the 8th, square root of b. Annalise, which one of these is perfect? Yep, this is the only one that's perfect. So it's actually pretty easy. Circle what's perfect. If there's an even number exponent, what do we do? Alyssa. Good, divide it by 2, so we get a to the 4th. Square root of 15 and square root of b get mushed together because unfortunately they're not perfect. So they get thrown inside the square root symbol by themselves. because x to the 5th you break down into x to the 4th times x to the 1st. The square root of x to the 4th is x to the 2nd. Okay? Mary. Frodo. Can't do it.
I got number 11.
Okay. Tell me what you have. That's weird. I don't know why you have a 4 in front. All right. So 11. So you probably broke it down into square root of 16, square root of 6, square root of b, square root of c squared, square root of d to the 4th, square root of d to the 1st. Oh, nope, we can do it your way, but let me, so you did 24 and 4. Okay, I'll do it your way. This is perfect, this is perfect, this is perfect. Square root of 4 is 2, square root of c squared is c, square root of d to the 4th is d to the 2nd. Okay, and then, did you change 24 to 6 and 4? Okay, so square root of 6, square root of 4. I'm going to rewrite BD because they're not perfect. Mary, Frodo, what's the square root of 4? And then you multiply it in front. So you just forgot that last step of multiplying. So you get 4cd squared square root of BD. Got it? Okay. John. Yeah, where'd my 6 go? Thanks. Emma, I'm glad you're sitting up here. Okay, go for it. Sorry. Sure. Ganda, I know. I got to learn that one tomorrow. I'm trying to get Manatee Frodo down here. Tomorrow I'll do the Emmas. Okay, Arwen. I'm not a Lord of the Rings person. Arwen. All right, anyone else? Questions on the homework while I'm learning these crazy names? We're going to do more today. Sean, do you need me to go over one?
No, I think I got all.
You sure? Okay. All right. Give me a thumbs up, thumbs middle, thumbs down on what we just went over. We're going to do more today. I just need to see where you guys all are. Charles? Okay. Oh, good. You're learning the perfect square. So when you randomly come in from the restroom and I yell something out, you'll know how to answer it? Maybe. That doesn't sound like you're confident. All right. All right, guys. Open up your notes to page 5. Open up your notes to page 5. Frodo, what's 15 squared while you're doing this? Notes page 5. Donatus, while you're opening your notes, what's 16 squared? Donatus? Oh, no. We're in big trouble. Donatus said 16 squared is 4. Say it again. 16 squared. Okay, no. No. 256. Sean, 17 squared. 2. Okay, you're looking. Briar, 18 squared. Donatus says there's too much pressure. Because I'm just yelling out at you. We should do this more often. Briar, 18 squared is 3 something. There we go. Emma M, 19 squared. Awesome. Justin, 20 squared. Good. Charles, 14 squared. You told me you had them memorized at the 15. Yeah. No. Hey, Charles, you're slacking. Manatee. Good, 196. Okay, Donatus, back to you. 13 squared. Hey. You're going to be eliminated. One what? There we go. Annalise, 12 squared. I can't learn all these at once. Annalise, 12 squared. Say that again? Okay, good, 144. Adam, 11 squared. Briar, 10 squared. Jeremy, 9 squared. Emma H, 7 squared. Good. Matt, 8 squared. I know, but I'm thinking about all these numbers in my head right now, so give me some time here. 8 squared. Come on. Manatee, 8 squared. All right. Alyssa, 5 squared. Good. Justin, 15 squared. Sean, 16 squared. That's all right. I'll go to someone else. Zach, 16 squared. Good. 17 squared, Frodo. Nope. 280. Nope. Think about it. 7 times 7 is 49. It has to end in a 9. That's what goes through my head. Shh, shh. Hey. Okay, one more. Emma H, 18 squared. Yes. And I lied, one more. Donatus, 19 squared. You always start off with the completely wrong number. Good. There we go. You got it. All right, guys. We're getting there. The timed quiz will be good one of these days. All right, ready? Oh, yeah, when you least expect it. Okay. The quotient property of radicals on page 5 in your notes is this. The square root of A over B equals square root of A over square root of B, where A is greater than or equal to 0. Donatus, you okay? And B is greater than or equal to 0. The quotient property of radicals says, just like the product property, you can split up the division and change them both to square root of something over square root of something. Now, my only problem with this is you are not allowed to leave a radical in the denominator, okay? So your book does not do a very good job with that. There are some problems they give you where they leave a radical in the denominator, but they don't tell you how to get rid of it. So if there's time today and you guys are okay with what I'm teaching you, I'm going to show you how to get rid of it, even though the book does not. So an example, square root of 64 over square root of 100. You can break it up into square root of 64 over square root of 100. This is why I keep going over these perfect squares. So Sean, what's the square root of 64? Good. Briar, what's the square root of 100? Good. So it's 8 over 10, which of course can be simplified further. So Adam, 8 over 10 is what? Yeah, it's a fraction. So after you square root it, you have to reduce your fraction if possible.
Oh, I thought you meant that the fraction couldn't be simplified.
No, can be. Can be simplified further. Well, I meant to say can. I don't know what I said. Sorry. Okay, so quotient property of radicals is very similar to product property of radicals. Okay, example A, we have square root of 13 over 10. 13 over 100. The first thing you do is separate them into square root of 13 over square root of 100. Alyssa, which one of those is perfect? Hey, that's okay. I teach them from 7:30 to 8:30. That's okay. Do you need me?
I just wanted to
That's fine. 6th grade, give me actually finish simplifying that one. That one's easy. That's all right. I didn't know. Whenever someone's here, they always like stare at the door, and I figured you were. So I'm almost there. Okay. 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 Look at you. Busy, busy, busy. Yeah. Oh, of course. Of course. You're welcome. Everything good? Good. All right, Donatus, which one of these is perfect? Good. Square root of 100 is perfect. So square root of 13 over 10 is the answer. You are allowed to leave a radical in the numerator as long as it's completely simplified. The denominator, you are not allowed to leave a radical. I will show you how to get rid of it if that happens, but you really need to listen because it's a little confusing. Let's do some of the other easier ones before I get to that. Letter B, square root of 1 over y squared. Split it up into square root of 1 over square root of y squared. Emma H, what does that simplify to? What's the square root of 1? 1? Oh, man, we're all losing it today. Emma H, what's the square root of y squared? Good job. Now you're good. You're back with us. Annalise. Mm-hmm. Why would you move it? Nothing's negative. It's only negatives. This has nothing to do with the negatives. Now, Annalise, there could be fractions that after we square root them, the exponents could be simplified. That could happen. But you're not going to have negatives. If you have negatives, it ends up being imaginary, which I'll hopefully tell you guys at the end of the year what those are like. Well, because I have to get you guys to a certain point, so when I leave to get married, you're kind of more independent. I don't want the sub teaching you everything. All right, I'm just particular about how certain things are explained to you. Letter C, Frodo. 2 days before the wedding, 2 days after. I'll talk more about that next week. Yeah. Sean, go ahead. Possibly, yeah. Charles. I thought you had your hand up. All right, letter C. First thing you do is split them up into square root of 169 over square root of 196. Alyssa, go for it. Good. So that simplifies to 13 over 14. Once you take the square root of each of them, they're both perfect. You'll be sick of these perfect squares by the time I leave next week. Okay? Hey, guys. Yeah, I'm getting married next weekend. Not this weekend, but next weekend. That's why I don't want to mess around, because I want to get you guys to a certain point before I go. Not this Saturday, but next. May 11th is my wedding. I just picked up my dress last night. All right, letter D. Trying to control my excitement, Sean. Adam, tell me what to do first. Okay, Adam, which one of these is perfect? Good. So I'm going to circle this. Jeremy, what's the answer? Good job. Adam. Square root of square root? Why do you need two square roots? Oh, no. I see what you're doing. Okay, so this is perfect, Adam. Since this is perfect, you're taking the square root of it. When you take the square root of it, it goes out of the square root house. So this is just hanging out by itself. You can't take d squared and divide it by 2 just because you feel like it. Okay, it's d squared. It's not square root of d squared. That's a common, 9th graders do that all the time. Don't do that. Do you understand what I'm trying to say? Okay. Annalise, they always mess up. Oh, yeah, hold on. If it's not a perfect square, yes. Jeremy. No, they just make silly mistakes sometimes because they don't listen as much as they should. I don't have Tanner. All right, you know what? Let's do letter F first because letter E is hard, but I do want to do letter F with you. Well, I would wait for me. There's a lot to that one. Okay, letter F. Why is this one different? Who can tell us why this one's different? Justin? Okay, that's one reason. Manatee, why else? Good, there's no perfect squares. So the first thing we do is we split it up into square root of 125 over square root of 45. Can someone tell me the largest perfect square that goes into 125? Zach? How many times? Okay, good, 5 times. So square root of 25 times square root of 5. What is the largest perfect square that goes into 45? Emma H? Say that, good, 9. How many times? I swear I'll get your name tomorrow. Good, 5 times. So square root of 9, square root of 5. Now, Sean, in the numerator, what can I circle because it's perfect? Good. Circle the 25 because it's perfect. Charles, what am I circling in the denominator? Good. So here's where it gets kind of tricky. The square root of 25 is 5. Rewrite the square root of 5 that's already there. In the denominator, square root of 9 is 3. Rewrite the square root of 5 that's there. Hold on. Emma, go ahead. Just say what you just said. Okay, why do they cancel? Yep. Square root of 5 divided by square root of 5 is 1. Okay, don't ask me why. It's the same number. 3 divided by 3 is 1. 5 divided by 5 is 1. Square root of 5 divided by square root of 5 is 1. So even though you're not allowed a radical in the denominator, In this case, they were the same. If they cancel, that's good. Makes it easier for you. So your final answer is 5/3. Completely simplify. Remember, this is equivalent to the original problem. Donatus. I don't know, because I don't have mine finished on here. We're going to do it next. So, Mary. Okay, hold on. Questions on F. All right, let's do letter E together. Okay, so I'm going to do it with you guys. We're going to do one step at a time here. If you're ahead of me, please check. All right, so square root of 32x cubed over 50c squared. All right, first step, split them up, okay? Square root of 32x cubed over square root of 50c squared. Okay, split them up. Next step. Oh, c to the 6th. What am I doing? Thanks, Emma. I really like you in front. C to the 6th. I'm so used to it always being squared, that's why. I don't know. Okay, so after you split them up, we need to figure out what perfect square goes into each of them. So what's the largest perfect square, Annalise, that goes into 32? Good. Square root of 16 and square root of 2. Emma H., what can we split x cubed up into? Good. X squared and x. So that's the top. Let's take care of the denominator. What can we change square root of 52? Emma M. Good. Square root of 25 and square root of 2. What about c to the 6th? Are we splitting that up or leaving that alone? Frodo? We are? C to the 6th. Yeah, why, Donatus, are you okay? Okay, why are we leaving it alone, Frodo? You're right. Good, it's an even number. All right, at this point, Jeremy, on the top, what can we circle because it's perfect? Okay, got it. Okay. Manatee, what's the square root of 16? Manatee, what's the square root of x squared? Manatee, what stays inside the square root on the top? Alyssa, what's the square root of 25? Good. What's the square root of c to the 6th, Alyssa? 3? Good. C to the 3rd. Alyssa, what stays inside the square root? Good. Okay, now, here's the problem. You are not, they do not cancel. You are not allowed to have a radical in the denominator. Why do they not cancel? Why do they not cancel? Frodo. Yeah, one of them's a 2x and one of them's a 2, okay? You could, but we're not going to do that. I'm going to show you how to simplify it like this. Donatus, what'd you say? Right, that's what I just said. You could cancel the 2's, but we're not going to, because I want to show you how this works. You could. Yes, but let's pretend like they don't cancel. I want to show you how to get rid of it. So the point of this problem is I want to show you how to get rid of a radical in the denominator. Yeah, you can cancel them and just leave it as x in the top, okay? But if this radical was a different number, and I'm not going to change it, to get rid of it, you multiply the top and bottom by square root of 2. Here's why. What's square root of 2 times square root of 2? Alyssa? Square root of 4. What's the square root of 4? 2. So the denominator is 5c cubed times the square root of 4, which is going to turn to 2. If you multiply the top and bottom by the same thing, it's going to cancel the radical in the denominator. I'm going to rewrite the numerator, which is 4x. What is the square root of 2x times the square root of 2? Charles? Good, the square root of 4x, okay? So hold on. So now at this point, okay, let's take care of the numerator. We have 4x. Which one of these is perfect? The 4 or the x, Charles? Good. What's the square root of 4? Good. So I'm going to put a times 2 here and rewrite the square root of x. Do you guys understand where this 2 came from? Emma? No? Okay, I won't skip steps yet. You guys aren't ready for that yet. Okay, so back up to this step. The reason you multiply by the square root of 2 in the numerator and the denominator is to get rid of the radical. Yes, you multiply by the same number every time. Annalise, go ahead. Whatever the radical is. No. Whatever's on the bottom, you multiply by on the bottom and on the top. The top has nothing to do with this. You're not allowed to have a radical in the denominator. Okay? So you multiply the bottom and top by what's on the bottom. You guys don't, just so you know, you don't have to know this. This is something in algebra. Okay? You should still try to, it could be a bonus at some point, but Sean, what's wrong? So to get rid of, I'll say it one more time. To get rid of a square root in the denominator, you multiply the top and bottom by this number. You have to get rid of it. So square root of 2 times square root of 2 is square root of 4. Square root of 2x times square root of 2 is square root of 4x. At this point, we're just separating them and simplifying. The bottom is 5c cubed times 2 because square root of 4 is 2. Sean. Yep. So the bottom would be 10c cubed. Sean, what would the top be? Good. 8x square root of x because the square root of 4 is 2, like Sean told us. And 2 times 4 is 8. Now, Alyssa, what else could we do? Is there supposed to be a square above the 8x? No. No. Because this square root of x stays here. No, there was never a 4x squared. It's 4x, Alyssa, because the square root of x squared is x. Okay? There's one more step, Justin. Good. So your final answer is 4x square root of x over 5c cubed, which, like I told you guys before, if these numbers are the same, you can just cancel them. But I just wanted to show you one problem of how to get rid of a radical in the denominator. But I'm going to do one that's more simple so it's easier for you to stay with me. Yes, Annalise? Because you have to simplify it. 4 is perfect. So we're breaking it down. We're using the product property of radicals from yesterday. We're breaking it down into square root of 4 times square root of x because 4 is perfect. It's like a regular radical, Annalise. If it was like this, how would you simplify that? Yeah, we're just simplifying. Okay. Okay, let me, on the bottom of your paper, write this problem down. 5 over square root of 3. Okay, what's wrong with this? Donatus, what's wrong with this? Okay. Okay, hold on, I'm sure you do. Okay, there's a square root in the denominator. You're not allowed to have a square root in the denominator. How do we get rid of it, Emma H? It is, but I want to make sure you guys are all with me. So Emma H, are we multiplying the top and bottom by square root of 3? Good. I'm just making sure everyone's on the same page as me because I feel like some of you are completely not. I could be wrong. Okay, so you multiply the top and bottom by the same thing. You can't multiply by different things. You can't change the value of it. It's like an equation. What you do on one side, you do on the other side. Do not multiply by different numbers. That makes no sense. So 5 times the square root of 3 is just 5 square root of 3. What? No. Square root of 3 times square root of 3, Alyssa, is the square root of 9. The product property of radicals says multiply them together. 3 times 3 is 9. Okay? Square root of 3 times square root of 3 is square root of 9. Jeremy, what's the square root of 9? Good. So your answer is 5 square root of 3 over 3. Does that make more sense? Okay. questions on that one? Mary? Oh, that's good. I like to hear that. I thought you guys weren't with me, so that makes me good. Good. That's good. That's a good thing. But do you have a question for me on this one? Okay. Donatus. A squared inside a square root or a square root inside a square root? That won't happen, but that's really like putting it to the 1/4 power. It's really like the 4th root. If there's 2 square roots, but Donatus, you're in Algebra 2 thinking right now. We're in pre-algebra. Number 9 on what? Oh, on the back of what we did yesterday. Yeah, don't worry about that yet. Jeremy. The opposite of what? The opposite of F? Well, the answer's 5/3, but the problem's completely different. You know what I mean? The answers look the same, but the problems were different, you know? Okay, I want you guys to start your homework so I can make sure we're all okay. Let me think here what I want to give you. Oh, yeah. Let me do this first. All right. Homework is going to be in your packet, page 144, and also your book. But let's start with this first. 9.2C. I want you guys to do timeout. Hold on. Shh, quiet. Let me just find mine. Yeah, I want you to do 1 to 22. And hey, can you give me a second? I'll get it. Okay, guys, hold on. One more thing. Also in your homework packet, page 140, 1 to 12. And then your book, page 711, 1 to 30. Okay, I'm kidding. I can't keep a straight face anymore. No book homework. I'm kidding. the Emmas put me up to it. Sorry. All right. So all joking aside here, I'm being serious. Okay, Briar. Homework packet, page 144 and 140. You have a couple minutes to get started, so get started.